Problem 2, two-sample hypothesis testing. Ingratiation is defined as a class of strategic behaviors designed to make others believe in the attractiveness of one's personal qualities. Individuals use behaviors to influence superiors in order to attain personal goals. And there is an index called the Measure of Ingratiatory Behaviors in Organizational Settings, MIBOS, and it measures this type of behavior. It was applied independently to a sample of managers in the Southwest and to clerical workers from a large university in the Northwest. Scores are reported on a 5-point scale, higher scores meaning more extensive ingratiatory behavior. So what you want to test is the following. Do managers exhibit higher levels of ingratiation than clerical workers? And let's use all three alphas in our answer. So here is our sample size. 288 for managers and 110 for clerical workers. And if the information is given within a table, or I should say within the body of the text, you should always place it in the table just to make your life a little bit easier. The mean score for managers is 2.41 and a clerical worker is 1.90, and here is our standard deviations. So first of all, if you don't know what ingratiatory behavior is, it's a behavior or a verbal comment that is meant explicitly to make a person like you better in a business setting and then therefore extend greater benefits to you. So for example, when you tell your boss that he did a great job even if he didn't, or if you tell your employer that he looks like he's losing weight, things like that, that sort of make it more pleasing for you in a business setting with the eye towards getting a specific goal is what an ingratiatory behavior is. Okay, so we want to test if managers exhibit higher levels of ingratiation. So this question is our alternative hypothesis. So we would state it as follows. Do managers exhibit higher levels of ingratiatory behavior than clerical workers? So the null hypothesis is our reverse. They are less than or equal to. Now please note that at the surface it looks like they do. The score is 2.41 for managers and 1.9 for clericals. But is that difference enough for us to say it is statistically significant? Now since both samples when added together are large, we're going to use the z-score, and we're going to use the critical values from problem 1. So here we are. At a 10% level of error, our critical value is 1.28. So if we find a test statistic greater than 1.28, we reject the null. So then it appears managers have a higher level of ingratiation. At 5%, our critical value is 1.645. So if our test statistic is to the right in the shaded area, we would reject the null. So managers do exhibit, it appears, a higher level of ingratiation. And at 1%, our critical value is 2.33. So if our test statistic is in the shaded area, then we would reject the null. So let's calculate it. So here are our means. And since managers is in the first position for the alternative hypothesis, its score is also on average in the first position. So 2.41 minus 1.90. We subtract 0 because our formula does not say, or our problem does not say, we wanted to see this difference to be 0.5 or 0.25, so it's 0. Here is our standard deviation squared divided by our first sample, plus our standard deviation squared divided by our second sample. We calculate this out, this becomes 7.17. Now if you go to your Excel sheet, you'll notice that here are the critical values, and our z-score, I plug the formula in. So if you change any of the inputs, the z-score would change as well. Okay, so going back to our problem, the critical values are clearly to the left of your test statistic. So 7.17 falls in the shaded area to the right at 10%, 5%, and at 1%. So in this case, your conclusion, unlike the first problem, is clear. So at 10%, we reject the null. At 5%, we reject the null. and at 1% we reject the null. So you reject it at all levels of alpha, so it appears that managers exhibit higher levels of ingratiation than clerical workers. When you reject the null, there's always the possibility of a type 1 error, and to calculate that probability, let's go back to our Excel sheet, and you'll see that when we plugged in our p-value, 0.5 minus b27, you'll find that it's practically 0%. So use the Excel templates to sort of adapt as you go through the homework problems or to recalculate some of the problems that you see here so that you can focus less on the equations and more on the analysis.